Hello and welcome back. We're going to continue our discussion on transforming the domains using our Jacobian substitution. And in this example right here, we're given a region bounded by the hyperbolas xy equals 1 and xy equals 3. Also the horizontal lines y equals 2 and y equals 6. And we want to determine what our new region would be if we apply the following transformations. Remember, this is a substitution, kind of like U substitution, but right now we're just worried about changing our domains. So we're going to change our x's and y's in terms of u's and v's. So to begin, let's just take a look at how nasty this would really be right here. So the first thing I want to do is I want to look at the old region. This is what the original region would look like. To graph this, if you need to, just remember xy equals 1 is just y equals 1 over x, and of course xy equals 3 is just y equals 3 over x. So I can look at that real quickly. Let me see here. We're going to just look in the first quadrant here. So let's see here. So because in the third quadrant we don't have to worry about these little intersections right there. So in the first quadrant we got this 1 over x, which looks like this, and then we get 3 over x, which looks like this. And then we have to look at the lines y equals 2 and y equals 6. So I'm not going to draw this to scale here. There's y equals 2, and here's like y equals 6. And when we look at the region that we are trying to find the area of, right away we should notice that this is going to be pretty nasty to do. I mean, think about this integral that we would have to write. How many integrals do we have to write? If we were to draw like a vertical rectangle here, look at this, 1, then 2, and then like 3, possibly 3, maybe 4 integrals here. Of course, we can always change it to go sideways, and that would be a little bit easier for us, of course. But let's apply the transformation. So clearly this is difficult. This is not a very easy one to do. So let's see if what our, can't spell difficult today. There we go. This is difficult. So let's see what our transformations would do. And we're going to go and do those. We want to replace. Remember, when we are going to replace, we are substituting. We're going to substitute to get u's and v's here. So we want to get rid of the x's and y's and make them u's and v's. And I get complaints that my u's, my v sometimes look like u, so let me see if I can draw that a better v right there. Alright, so let's go and look at the first one. The first one, of course, is x, y equals 1. Let's apply our substitution. This is v over 6u times 2u equals 1. And of course, the u's will cancel, and we're left with, let's see here, v would equal 3. Oh, already much easier. Remember, this is just going to be a horizontal line, v equals 3. So we got this rational function that transforms into a horizontal line right there. That's much nicer. The next one, let's try xy equals 3. Same thing. v over 6u times 2u equals 3. The u's again will cancel. And of course that becomes 1/3, so v equals 9. So again, this transforms into a nice horizontal line. Y equals 2, whoops, sorry about that. Y equals 2, well, y is 2u, so 2u equals 2, so u equals 1. A nice vertical line right there. And let's see here, the last one, y equals 6. We get 2u equals 6, so u becomes just 3 right there. Oh, very nice. So my new domain, if I were to graph this, sorry about that, I don't know what's going on there. We got, remember, my u's and my x's, we're going to treat our v's like our y's. So my u's go from 1 to 3, and my v's go from 3 to 9. And if we look at this region right here, it's just a very, very nice rectangle. So remember, this is the region. This region is x, y, x and y's, but in terms of u and v. So I can now use this to get my limits. So I'm going to do a vertical rectangle. That's going to be my change in v's. So my v's are going to go from 3 to 9, and my u's are going to go from, and we're going to make this go left and right, 1 to 3. And that would be our new limits. And now I only have to deal with only one integral versus 2, 3, maybe 4 integrals on something like this. Alright, so that's that one. Okay, so we've been talking about how we change the base, how we change the domain. In other words, remember, like when you use substitution, we talked about how we can change the domains. Now we're going to start talking about how we change the function itself that we're going to be integrating. To do this, we need to discuss, we need to start talking about how we actually change the variables inside the integral. So when you do use substitution, you might recall, let's go here to blank sheet of paper, when we did use substitution like last year, like something, let's say we had sine of 2x dx, do something easy, let's say from pi over 3 to pi over, I should go pi over, let's go 5 pi over 6, make it look better. There we go. When we did our u substitution here, we would let u equal 2x, our du would be 2 dx, give me dx equals du over 2. Notice, we changed the inside. So my inside is now going to be sine of u times 1/2 du. Notice, we changed the inside. We're dividing it by 2. So when we do a u substitution, we change the inside a little bit. We don't just replace the 2x with u, it changes the inside of our function. And of course we use derivatives to do that, to help us change that inside. And of course we also changed our domain. This is what we've been talking about. When x is pi over 3, we could say u is 2 pi over 3. So this would go 2 pi over 3. And when x was 5 pi over 6, we would say u is 10 pi over 6, whatever that is, I don't know. 10 pi over 6. I think it's 5 pi over 3. Alright, so anyways, what goes on here is we change the domain, and this is what we've been talking about. This is that Jacobian substitution that we've been talking about up here. We change the domains, but we also change the inside. And that was, of course, we used the derivatives for that. So what we're going to talk about now is how do we change the interior part of our integral. And to do this, we use something called a Jacobian matrix. Okay? We use something called a Jacobian matrix. And we're not going to talk about where it really comes from, but what I want you guys to notice is when you look at the Jacobian matrix, this is it right here. This is what we use. It is a determinant. Whoops, not matrix. I guess I should say more specifically, it's a determinant. Okay, it is a matrix, but we're going to take the determinant of it. What we notice here is, in the inside, it is our partial derivatives. It's a matrix of our partial derivatives. And look that we've done here. We have our partial derivatives right here as well. So today we're going to talk about how we can determine what the Jacobian matrix is. We use this to change variables when evaluating integrals. So when we're trying to change variables using integrals, we have to use this Jacobian determinant. This is going to help us transform the function. And notice again, the elements here are partial derivatives. So let's take a look at this one. Here it is right here again. And this is just, remember, how to take a determinant. Remember, you're going to do cross product, cross multiply. Going down, you're going to make it positive. So you get the partial of x with respect to u, the partial of y with respect to v, minus, because going up, the partial of x with respect to v, the partial of y with respect to u. So let's just practice using the Jacobian, finding the Jacobian determinant. So we want to compute the following Jacobian determinant. So we're going to need our partials. Notice, I'm going to go in the order. We need the partial of x with respect to u and the partial of x with respect to v. So I'm going to go ahead and find those. The partial of x with respect to u is just 4. The partial of x with respect to v is negative 6v. On the bottom second row, we're going to do the same partials, but now with respect to y. Partial y with respect to u, partial y with respect to v. So we take the partial of y with respect to u, oh, here it is, which is just 2u, and the partial of y with respect to v, which becomes negative 6. And we're going to do this. This becomes 4, negative 6v, 2u, minus 6. And when we negative 6, and when we do the determinant, we're going to get negative. When we do the determinant, we get negative 24 minus, and going up, we're going to get, that just becomes negative 12 u times v. Now, remember, when you're doing a determinant, notice you have to have these vertical bars. No hooks. You can't put any hooks on them. That's a matrix. That's different. We're looking for an operation, which is the determinant. And if you simplify this, we get negative 24 plus 12uv. And there's our determinant. And there's our Jacobian determinant. Now, tomorrow, we're going to put this all together. In the next lesson, we're going to put this all together, how we actually use substitution in multivariable integrals. Substitution. All right, so let's try the next one here. We need the partial of x with respect to u, the partial of x with respect to v, the partial of x with respect to, the partial of y now, with respect to u, and the partial of y with respect to v. All right, so let's go ahead and find all these partials here. With respect to u, we get 2u v cubed. Partial of x with respect to v, 3u squared v squared. Partial of y with respect to u. All right, this is just the derivative. Remember, the derivative of square root is just 1 over 2 root u, and those 2's will cancel, so we just get negative 1 over root u. And the partial of y with respect to v, there's nothing there, so it's just 0. All right, so we do here, we got 2u v cubed, 3u squared v squared, negative 1 over root u, high root for u, and 0. And it's not too bad to do. Don't forget your little bars there. This becomes 0 minus, all right, this ain't going to be pretty, negative 1 over root u times 3u squared v squared. And if you simplify that, that just becomes 3u squared v squared over root u. Root u. There we go. And there's our answer. Alright, so I hope you enjoyed the videos. Remember, tomorrow we're going to take a look at how we're going to put all this together with our integral. So we're going to have our u substitution. We're going to talk about changing our variables on the inside, combine that with changing our domains and variables, and then we're going to integrate. Alright, I will see you then. Bye-bye.